Have I do that?
Yes.
You must see that.
Yes. It's clear.
Okay.
Yeah.
It's not speaker mode, right?
Yes. So all the panelists in here, all the speaker can share the screen.
Right. I'll stop the showing.
Okay. Thank you.
So the conference might start in 9 o'clock, and then in Indonesia, right?
Yes, that's right.
Right. And
お平さん、この発表資料っていうのは公開しても大丈夫なものですか？
多分大丈夫。大丈夫。
かしこまりました。
じゃあ消しときますね。
Thus, good morning, everyone.
Okay, good morning, everyone. On behalf of the organizer, we welcome all the honorable speakers. We really thank you for your time to attend our webinar. So soon we all will start this webinar. So for the Master of Ceremony, you can start by checking the sound and everything.
Okay, good morning, everyone. I hope you can hear my voice clearly. Okay.
Yeah, it's clear. Okay, thank you. So in next 2 minutes, we can start this webinar. Okay, thank you.
Okay. Good morning, ladies and gentlemen. It is my pleasure to welcome everyone to today's webinar. The Honorable Ms. Yoshiko Yurugi, Chief Representative NEDO, Asian Representative Office in Bangkok, and also to our honorable speakers, Mr. A.G. Ohira, Dr. Insinyur Dadan Kusdiana, Master of Science, Professor Dr. Engineering Enia Listiani Dewi, Master of Engineering, Dr. Muhammad Abdullah bin Zaidel, Professor Dato Insinyur Dr. Wan Ramli Wan Daud, Mr. Motohiko Nishimura, Mr. Satoshi Tanimura, Mr. Shinji Kondo, and Mr. Masaki Sakamoto, and all respectable participants for Future Outlook of Hydrogen and Energy in Southeast Asia, featuring Indonesia and Malaysia webinar. I am Adisti Gaisani. On behalf of NEDO, we are pleased to welcome all of you to the Future Outlook for Hydrogen Energy in Southeast Asia, featuring Indonesia and Malaysia webinar. This webinar was organized by the New Energy and Industrial Development Organization, NEDO, which is a Japanese government research and development management agency. Today's webinar will be divided into two sessions. We will begin the first session with the topic, energy policy of each country and outlook for hydrogen energy. And then we will have a 15 minutes break, and followed by the second session with the topic, introduction of Japanese hydrogen energy solutions. And I would like to inform you that in this webinar, there will be no Q&A session. So if you have any questions, you can submit all your questions into the questionnaire that we will provide by the end of the webinar. Before we start, we would like to listen to the opening remarks that will be given by Ms. Yoshiko Yurugi as the Chief Representative of Asian Representative Office in Bangkok of NEDO, Japan. Ms. Yoshiko Yurugi, time and screen are yours.
Well, thank you. And good morning, everyone. My name is Yurugi, Chief Representative of NEDO, Asian Representative Office in Bangkok. I'd like to thank all participants for attending our webinar. Also, I'd like to take this opportunity to thank Mr. Dadan Kusdiana, Professor Enia Listiani Dewi, Dr. Muhammad Abdullah bin Zaidel, Professor Wan Ramli Wan Daud, and all Japanese speakers for their cooperation in the lecture. NEDO is a public project management and funding agency under the Ministry of Economy, Trade and Industry of Japan. NEDO aims to create innovation by promoting technological development. In Japan, we provide support to companies and research institutes in energy fields such as renewable energy, energy saving, and hydrogen energy. We also cover industrial technology fields such as AI and robots. In the field of hydrogen energy, which is also the topic of today's webinar, Japan has played a leading role in the world. In 2009, Home Fuel Cell Cogeneration System, NFRM, and in 2014, the fuel cell vehicle, FCV, were commercialized for the first time in the world. Furthermore, Japanese government announced the basic hydrogen strategy in 2017, which is the first national strategy for hydrogen in the world. Since its establishment in 1980, NEDO has played a core role to promote technology development of hydrogen energy in Japan for a long time. We are promoting carbon neutral energy used by developing elemental technologies and building supply chains for the safe use of hydrogen from the perspectives of production, storage, transportation, and utilization. Recently, the efforts toward hydrogen in the world have accelerated significantly. NEDO, together with the Ministry of Economy, Trade and Industry, held a hydrogen energy ministerial meeting in which 35 countries, regions, and organizations participated apart from technology development. It also extending to global harmonization. This webinar is targeted at Indonesia and Malaysia. Indonesia is rich in natural resources and has the potential to produce consume and supply the most hydrogen in the region if the conversion to green energy progresses significantly. Malaysia is also rich in natural gas and an important partner for Japan. The state of Sarawak is already making efforts to build a hydrogen economy. It advances other regions in Southeast Asia in hydrogen utilization. When the era of mass production and mass consumption of hydrogen arrives, we believe that both countries can become important partners for Japan. I also hope Indonesia and Malaysia will get to know each other's current situation and form a new cooperative relationship, including exchanging information with each other. Our activity has stagnated due to the coronavirus pandemic, but our thoughts are not affected by it. I hope this webinar will help you think about what you can do when the coronavirus eases. Through this webinar, I hope for new collaborative projects between Japan and Indonesia, Malaysia, and the rest of Southeast Asian countries. NEDO will cooperate with the government agencies, while Japanese companies will cooperate with private companies in each Southeast Asian country. I'd like to make efforts to create a win-win relationship between the two countries. We are also looking forward to hearing from you about specific cooperation, so please feel free to contact NEDO. Last but not least, we'd like to express our gratitude to all speakers and the related organizations supporting this webinar. Thank you very much.
Thank you, Ms. Yoshiko Yurugi, for the remarkable opening speech. So ladies and gentlemen, without any further ado, we will proceed to our first session of the webinar with the topic, Energy Policy of Each Country and Outlook for Hydrogen Energy. There will be 5 speakers in the sessions, which are Mr. Eiji Ohira from NEDO, Japan, and Dr. Ingenieur Dadan Kusdiana, Master of Science from Ministry of Energy and Mineral Resources, Indonesia. And then we have Professor Doctor of Engineering Enia Lisiani Dewi, Master of Engineering from Agency for the Assessment and Application of Technology. And we have Dr. Muhammad Abdullah bin Zaida from Economic Planning Unit Sarawak. And then we have Professor Dato Insinyur Dr. Wan Ramli Wan Daud from National University of Malaysia. So the first speaker who will do his presentation is Mr. Eiji Ohira. Mr. Eiji Ohira is the Director General of Fuel Cell and Hydrogen Technology Office, Smart Community Energy Systems Department of New Energy and Industrial Technology Development Organization, NEDO, Japan. He joined the NEDO in 1992, just after he graduated from Tokyo University of Science. Before taking up his current positions in April 2013, he served in several positions, including Representative at NEDO Asian Representative Office and Director of the Energy Storage Technology Division. So please welcome Mr. Eiji Ohira. Time and screen are yours.
Okay. Well, sorry. Okay. Can you see my slide, or can you hear me?
Yes, we can, Mr.
Sorry,
Adrian.
I'm sorry keep waiting you. Well, good morning and selamat pagi, everyone. And first of all, I thank you for everybody who's joining this conference. I'm very happy to be here to introduce our current activity, our future activity toward zero emission or realizing the hydrogen society. Today, I bring some kind of information about the Japan current policy and the NEDO's activity on R&D for hydrogen and fuel cells. So let me start our current Japan policy. And we have energy policy, but the latest one is the carbon neutrality. In October last year, a Prime Minister declared that Japan would achieve the carbon neutrality by 2050. To address this challenging target, the Ministry of Economy, Trade and Industry will formulate green growth strategy achieving the carbon neutrality in collaboration with related ministry and agencies in December 2020. That strategy is an industry policy to reach a challenging goal, achieving carbon neutrality and aim toward positive cycle, economic growth, and environmental protection. This figure shows just an image how to achieve the carbon neutrality. And the current emission is kind of 1 billion carbon dioxide emission from the energy sector. In 2050, promote conversion to the electricity. Zero emission power sector be addressed, such as renewable energy, the fossil fuel CCS. That's a percentage, just image, but this policy will be discussed in the near future. And this figure shows 14 priority field or industry to be promoted on the strategy toward carbon neutrality. Upholding high goal for each of 14 priority fields, that the strategy formulate action plan covering comprehensive policies and such as budget, tax, regulation reform, standardization, and international cooperation. Hydrogen itself is one of the promising industry. And also hydrogen and its application fuel cell appears in other industry like mobility and maritime to aviation, etc., etc. I mean, you may understand that hydrogen is not only solution for carbon neutrality, but play very important role. This is the outline of the current hydrogen policy, namely basic hydrogen strategy, as Yuri-san mentioned that. And this strategy is based on our previous target. Previous target is minus 80% degrees by 2050. And under the current to new policy, carbon neutrality 2050, this strategy might be revised in near future. And this strategy is a kind of future vision and an action plan toward 2030. Our goal is to reducing the reducing hydrogen cost to the same of the current conventional energies, maybe $2 per kilogram. We also set the benchmark for 2030, such as number of fuel cell vehicle, or number of stationary fuel cell, or number of hydrogen filling stations, etc., etc. I will talk about our current status of the hydrogen and fuel cell application. And our target is here, and on the current status here. Our first commercial project, residential fuel cell, we have already 380,000 units we only installed in Japan households. For the mobility sector, we already have nearly 5,000 fuel cell vehicles, including the 100 fuel cell buses. Hydrogen filling station, we're leading the world, and we have over the 140 hydrogen refilling station in operation. So next, I will talk about the private sector's initiatives. Japan's Hydrogen Association, or J2A, is an organization that works with various stakeholders to ensure that Japan continues to lead the world in the use of the hydrogen. J2A was established December 2020 with 90 component participation. And its activity is very wide and is proposing and coordinate a social implementation project and investigate the creation of the fund and basic management operation, make policy proposal for generate demand deregulation, undertake international activities, collect, analyze, and disseminate information from Japan overseas. The Japan government may cooperate with this private sector's initiatives to promote the hydrogen. So next, I will to talk about NEDO's R&D activity on the hydrogen fuel cells. This slide shows is the current direction of our program. Our first step is to promoting the fuel cell application. Now we have been conducting the two types of fuel cell. One is PEFC, mainly for the mobility uses, and the other one is solid oxide fuel cell, mainly for the stationary applications. Through the discussion with the stakeholder like Toyota and Honda, we set a very ambitious target for the future fuel cells. To achieve this challenging goal, to address this challenging goal, we invite all the stakeholders, not only industry, but also the academia or universities. Developing a new application is a key to enhance the fuel cell market. We need to develop the fuel cell maritime applications, heavy on the middle duty vehicles, and the bus and trucks, and sometimes airplane or train, etc., etc. Okay, solid oxide fuel cell. Our challenge is how to improve the efficiency. Our target is over this 65%. This is almost same as a large scale or stationary power plant. The durability is other challenges. Our target is over 130,000 hours. It's almost equal to 15 years lifetime. The hydrogen filling station is a key to disseminate the fuel cell vehicles. Okay, our challenge is reducing the capex and the OPEX of the fuel cell hydrogen filling station, and also need to preparing the heavy duty vehicle, need to develop the refilling protocol, the hydrogen metering, etc., etc. Our next challenge is a wider use of the hydrogen, or developing the hydrogen demand and the integrated with other energy system. I'd like to say that the hydrogen scaling up. One challenge is developing the hydrogen supply chain or large scale hydrogen application. We already developed the hydrogen gas turbine. We need to also continue to develop the hydrogen boiler, the hydrogen engines. It's a work for decarbonization in the industry sector. Okay, power to gas is the key technology for decarbonization energy system or sector coupling. So I would like to bring some snapshot from our project, mainly hydrogen scaling up. This slide shows our first hydrogen gas turbine project. It's installed in a city area to provide heat power surrounded area like a hospital and a sports center, any other public facility. This is gas turbine. It's classic heavy industry technologies. Okay, so we can operate it. It's a dual fuel gas turbine system, but we can operate at 100% hydrogen with a low level of NOx emission. This slide show our other project is a hydrogen international supply chain. But the issue is how to concentrate hydrogen for the long distance transportation. One option is liquefied hydrogen. We already developed the small but water-first hydrogen tankers, and also we already developed the hydrogen handling equipment at the port, like loading and unloading liquid hydrogen, large-scale liquefied hydrogen storage. This slide shows our current activity on the megawatt scale of the Gas project. Let's slide show our first 10 megawatt alkaline water electrolysis Gas project. And right slide show we also developed the cutting edge technology. I will say that utilizing high performance, high efficiency hydrocarbon membrane is for the PEM water electrolysis. This megawatt scale gas system already developed, and our project demonstration will be started soon. Okay, let me conclude my presentation. Yes, and Japanese government still strongly promoting the hydrogen. That's a key technology for the carbon neutrality. We clarify the future vision and direction. Yes, we have already developed the market application, but I just started to market penetration. We need many information from the market, and it's just information we feedback to the next R&D activities. We also need to enhance application in both technologies. Our goal is developing the low carbon energy system. The keyword is scaling up and the integration. Okay, and hydrogen society can be developed by the one country. We need an international collaboration. I hope this opportunity is the first step for the future collaboration between Malaysia, Indonesia, and Japan. Okay. I'd like to close my presentation. Thank you very much for your attention, and terima kasih banyak.
Thank you, Mr. Eiji Ohira. So now we're moving on to the second speaker who will present the material. So please welcome Dr. Insinyur Dadan Kusdiana, Master of Science. Dr. Dadan Kusdiana is the Director General of New and Renewable Energy and Energy Conservation, Ministry of Energy and Mineral Resources, Indonesia. He completed his doctoral degree from Kyoto University, Japan, majoring in environmental and energy science. So please welcome Dr. Dadan Kusdiana. Time and screen are yours.
Thank you. Very good morning. Thank you, Mbak Adisti, for the introduction. So, very good morning to all of you. Selamat pagi. Assalamualaikum warahmatullahi wabarakatuh. Thank you for the invitation from NEDO. I really appreciate for this kind of initiative. So, to discuss something that quite new for us, and this is a very good opportunity also to learn, to see how's the development on this kind of new energy, this kind of the new technology implementation, and later on try to see how to implement here in the country. I would like to share the slide, try to share what is currently being in the implementation here in the country, in particular for hydrogen, but I would like to start with the renewable energy policies and implementation. And then at the end, I'd like to touch into the issue of hydrogen development in the country. I see here we have also Prof. Enia, who is the expert on the hydrogen technology. I think on technical issue, she will talk more than myself. I would like to start with providing the Indonesian commitment for the greenhouse gas emission. So I start with the common issues for all of us, for Japan, for Indonesia, I think also for other country, for Malaysia. So all countries are now having the commitment for the greenhouse gas reductions. And for Indonesia, the commitment is to reduce by 29% of greenhouse gas emission in 2030. And now actually we are discussing how to improve, how to have more ambition for the greenhouse gas emission, including setting the target of net zero emission. I heard that Japan has put the target in 2050, and for us here we are still in the finding the best way how to reach the target for the net zero emission. So we don't set the target in what year. Currently, we are still in the optimizing all any possibilities to have the target. So in total here for energy, the commitment from energy sector is 314 million ton of CO2 in 2030, in which half of that will be from renewable energy. The other half will be coming from the energy efficiency implementation and also the use of green energy technology. So here our achievement so far, the chronology is from year 2017 up to now, last year in 2020. So this is the comparison between target and the achievement, the realization. So far I can say that we are still on the target to reach the commitment in 2030. So even last year we are beyond higher than the target. So last year we could reach 64 million ton compared with the target of 58. So this is the tail of the data from energy efficiency, renewable energy. So I think we are still on the target. It's not only from the energy sector, but also from the agriculture as well as also from the forest. Next. How is then the planning to reach the greenhouse gas emission from this year 2020, 2021, and for the next 10 years? So we'll add more renewable energy into the grid. We will use more biodiesel for renewable energy as the substitution for the diesel fuel and also for others. And we try also to start with the program of electric vehicles as well as also the transition to low carbon fuels, and try also to use clean generation technologies, including the hydrogen, I think, for this part, whether this is by fuel cell for cars or by fuel cell for electricity. One initiative here to accelerate the implementation of renewable energy is we call here is co-firing. We work also with Japanese companies, providing us the input how to do the modification for the engine, for the technology in co-firing. And we have also the cooperation with another company in Japan also to start the study of co-firing by the ammonia. Yeah. So this is another example as the hydrogen carrier coming from whether this is coming from natural gas or from the coal gasification. So we will have the 23% Actually, this is a target for renewable energy in 2025, and 28% in 2030. It will be based on renewable energy, of course, also the electric vehicle to reach the target of the greenhouse gas emission reduction in 2030. So again, for Indonesia, the initiative of putting hydrogen as the other resources for new and renewable energy are very significant and very strategic. Next. How then we can reach the target for greenhouse gas emission and going to the net zero emissions? So the first, we put more green energy, including the hydrogen probably on this part. So renewable energy, electric vehicle, battery, hydrogen. I think three of them will be our game changer. It's not only for Indonesia, but I think for all countries. Having battery and hydrogen, I think that will change a lot of our energy ecosystem, yeah, including the greenhouse gas emission. We'll add more smart energy and smart grid, and also the low-hanging fruit for energy efficiency, the energy conservation to reduce the need of energy and also to increase the productivity. On top of that, we will still need the clean technology. Clean core technology, for example, the one that actually is being also in the development is the CCUS, the carbon capture, utilization, and storage. It will capture the CO2, so we'll have the zero emission, but I think we still need the zero emission technology, the net sink. This will be coming from the agriculture, and zero emission will also from forestry sector. So by combining this, we can achieve the energy independency with the sustainable development and perhaps sometime with the net zero emission. We are now trying to optimize all any resources in the country to create national energy resilience and independence, and try to reduce the import, in particular crude and gasoline, which is currently the import are being increased. And most of LPG used in the country are still imported. So we are trying to use, for example, to develop the methyl ether from coal through the gasification and for LPG substitution. And of course, we will increase the use of renewable energy with the priority on solar power plant, and also to optimize biofuel productions. Next. This is our roadmap up to 2035. So we'll use the substitution. We don't need to put the new technology rather than to utilize the existing technology. For example, the increasing the use of B30. Currently, we do putting the biodiesel 30% blending with the diesel fuel, and now we are in the process of the testing to increase the blending ratio. We will expand the co-firing program. Currently, we have 6 coal power fire plant being used with the blending of biomass with the coal, and then also converting diesel fuel through renewable energy implementation. We have, for example, around 5,000 of the diesel power spread out of the country and used in the remote areas. So we are trying also to substitute the use of the diesel fuel. And then, of course, we need to increase the renewable energy capacity. I think I'm also promoting the use of non-electric renewable energy application and non-biofuel. We can do, for example, for agriculture products for drying, for other processes. We can use the enthalpy from the geothermal. We can use the brine from geothermal for that kind of the application. Yeah. In the strategy, we put also the nuclear. So we are in the process of the finalizing the all and requirement to start the nuclear program, but of course there is no decision yet whether we go or no go for the nuclear implementation. Next. So what then beyond 2035? Of course, it has to be prepared from now to reach the target, to reach the clean energy development, to approach for the net zero emission. We put nuclear as one of the option, and the other option are hydrogen. As I mentioned, I think hydrogen and battery, this will be the game changer, who will be the first champion for this. I think that will be also determining the future for the clean energy development. So again, hydrogen will be the strategic and important aspect for the clean energy development. Next. So far, I think the implementation of the fuel cell, whether this is based on pure hydrogen or this is in the mixed fuel, for example, from the methanol mixed with water or from the natural gas, the use of the development technology, I think led by BPPT, which is Prof. Enya will be sharing on the progress, on the update. Actually, we have already in the, I may call this is in commercial implementation. Yeah. So far, we have around 800 units already implemented for the telecommunication application. Yeah. In particular for the tower of PLN. So they are using the fuel cell technology because of some reason, yeah. Because there are difficulty in the managing the diesel fuel and also the high quality of electricity coming from this kind of technology. So far, I think in terms of the technology, they are already development in the country. Yeah. I just discussed this morning with one of the provider of the fuel cell technology. So I see a lot of opportunities as well as also the challenges, how to bring this hydrogen and use as the very clean technology, very clean energy technology. Next. One example, this is the initiative coming from Pertamina. They have the project to use electricity actually coming from the geothermal, then to do the to produce hydrogen through the electrolyzer unit, and then use this hydrogen for another purposes in the Pertamina business. Yeah, because they use a lot of hydrogen in the refinery. So I think that this will be another interesting initiative, how to develop the green hydrogen from green energy, and also at the end we will have the very clean zero emission technology for the energy. So this is another example from Pertamina. We have also another initiative. Next, how to develop hydrogen, of course, coming from renewable energy, from solar energy. This is also utilizing water for the production of hydrogen through electrolyzing process. So this will be our pilot project. Probably we are still discussing with the provider of technology and try to see how the best support from the government. So we are combining the renewable and the hydrogen process as well as also the fuel cell for electricity in the area. Here is the tentative area is in Sumba. Sumba is located in Nusa Tenggara Timur, East Nusa Tenggara, so around almost 1,500 kilometers from Jakarta. This is the area that the solar irradiation is the best in the country. Yeah. So 1.4 times compared with the Java Island. This is Sumba, so we are discussing with the provider technology. In particular, I think this is from Europe on this. Next. Yeah, this is from geothermal. I think I mentioned already. Next. So that's all actually from my side as sharing what actually has been done and how the Ministry of Energy see the future of the use of the hydrogen energy. So again, thank you for inviting me here and looking forward for further discussion. Thank you.
Thank you very much, Dr. Dadan Kusdiana, for the presentations. First of all, ladies and gentlemen, I would like to remind you that in this webinar, there will be no Q&A session. So if you have any questions, you can fill out the questionnaire that we will provide you by the end of the webinar. So moving on to our next speaker who will present the materials is Professor Dr. Engineer Enia Listiani Dewi, Master of Engineer. Professor Dr. Engineer Enia Listiani Dewi is a Deputy Chairperson of Agency for the Assessment and Application of Technology Indonesia and Chairperson of Indonesia Association to Fuel Cell and Hydrogen Energy. She completed her doctorate degree in engineering in Advanced Research Institute for Science and Engineering Faculty, Department and Applied Chemistry, Waseda, University Tokyo, Japan in 2003. And also she promoted as professor in 2014. So I'd like to welcome Professor Dr. Enia Listiani Dewi. Time and screen are yours.
Assalamualaikum warahmatullahi wabarakatuh. Very good morning for everyone. Thank you, Nedo, for inviting us to be here, and greeting also for Mr. Dadang as Director General from Energy Ministry, and also my friend from Malaysia, my old very friend, Professor Ramli, and so on, and everybody as mentioned by Dr. Dadang previously, we are conducting the implementation of hydrogen since 2004, and we accelerate the implementation in the research of in the research field, and also the development of fuel cells and also hydrogen. So I will share about the our activity now has been done in Indonesia, but you know the policy is make a slight different target, yeah, and you know the research and development implementation is not continue. Even we started the research from 2004, but the policy of Indonesia is changing. So we are now starting again the implementation of fuel cells and hydrogen technology. So mentioning by Dr. Dadang that Indonesia have a target of new and renewable energy contribute by to 23% at 2025. We know that this target is so optimistic, and now exactly in 2020 we just achieved 16%, so it must be accelerated to reach the target. According to the energy outlook of BPPT, we know that transportation section and industrial sector is main field to be changed to do something that we can achieve the renewable target. So you know that fossil energy is still a main supply for energy in Indonesia. And looking for this, research and development are also focusing on the transition, transportation and industrial sector. Our research and development of hydrogen and fuel cell also go in these two sectors. According to the global demand of pure hydrogen, we know that in the 2018 is reached many comparing to the 20 years ago. And according to the Ministry of Energy, the current price of hydrogen from renewable energy sources is around 3.5 euro per kilogram. And by 2025, is expected to fall to around 1.5 euro per kilogram. But this price is not represent the Indonesia price. We still have to continue the feasibility study of how the hydrogen can be implemented in Indonesia, and we're talking about the price and the cost down of the hydrogen price. So talking about the hydrogen carrier, you know that Japan and also another country accelerate the implementation of the hydrogen. So they're thinking about the hydrogen carrier by mentioning liquid hydrogen, methyl cyclohexane, ammonia, and also compressed hydrogen. Now this field is attracting many interest of the Indonesia researcher to know more about this. And as mentioned by Dr. Dadang also, we Indonesia have a very long, very huge area of country. So we call it the west part and then the east part. The east part is more adaptable to the green hydrogen concept. So as in the green hydrogen concept, there is a need a PV and also wind offshore and also the PEM electrolyzer. This concept is good for the East Indonesia. You know that renewable technology to produce clean electricity, and also this concept can be accelerate the carbonization on hydrogen production and go to the chemical industries. So from the field of fuel cells, since 2012, we do some research on PEM electrolyzer. We do alkaline electrolyzer. We also do the proton exchange membrane electrolyzer, but the level is on the research. Yeah, we just go to the step of 1 kilowatt size, but we know this this concept is so challenging, and we have so many resources in Indonesia. I think the green energy, green hydrogen concept is very switchable in Indonesia. And next, our research topic, we do the biohydrogen production also. You know that palm industry in Indonesia is so big, and Dr. Dadang also mentioned biodiesel, yeah, biodiesel B30 implementation in Indonesia. We have many palm plantation. This palm plantation produce palm oil mill effluents that waste from the palm industry. So we join with the many institutions, academici, not only BPPT, but also the others university. We design of the production of hydrogen from POME, and we have a concept that we using the hydrogen and then methane production from biogas. We combine it, and then we want to use it in the internal combustion engine inside the palm industry. So since 2009, we accelerate the lab scale and then go to the pilot scale for 40 liters and then 1 meter cubic batch. And now this year, we also try to have a 100 meter cubic batch. This will be held in palm industry of PTPN 5 at Sumatra. Talking about the green hydrogen project, we collaborate with Toshiba. We start to talk this concept since 2018. Yeah, Toshiba make a memorandum of understanding, and we have initiation project and to implement it at Baron beach site located at Yogyakarta. And in the right side of this slide, we're looking at the PV and also the implementation of H21 from Toshiba. But this is still the design. So we want to accelerate this because in last year, the pandemic is converting this project and not has been realized. And I want to share about the Baron Technopark that's located at Yogyakarta. This is very nice place, and this location only dedicated for renewable energy. We have just 1 hour from Yogyakarta. You can many Japanese tourists also fly to Yogyakarta. We have wind turbine, we have a solar cell, we have also implemented a fuel cells, and we have also battery. We do the hybrid power of conditioner and inside that location. We combine this education plan of renewable energy to a tourism. So we know that we maybe go to the next slide. We have methanol PEM fuel cell also at that location, and we use it as a backup power. So now this location is very active. The activity of this location, we have many students come to this as educational tours. And then we have also a camping ground. This is a very interesting place. And we can see the wind turbine. We can see also the amphitheater of in that location. We can do more activity as combined between tourism and education. So also talking about the implementation of the hydrogen-based vehicle developing by BPPT and many other institutions, including university. Ministry of Industry make a automotive industry roadmap, and you can see at 2030, the vehicle technology of fuel cell has been started. So we must consider about this target, because this target is now have been refreshed, yeah, by the Ministry of Industry, and then this roadmap is still put the fuel cell vehicle at 2030. So sharing about the BPPT activity for fuel cells development, we're doing the stacking, we're doing making fuel cells, and also you know that we accelerating the how we can go for implementation of these fuel cells, including the biohydrogen. Next. We have also many collaboration with the industry and academici, and many students have been joined to this project. Now we continue to make the implementation of the hydrogen technology, making a new roadmap, but this roadmap is just done by BPPT design, but we need adjust to the Ministry of Industry, including adjust to the other university progress and also the industry of Indonesia progress. So we do also some research on the solid oxide fuel cells. We have implementation of the zirconia because these solid oxide fuel cells contained in the consortium of rare earth materials in Indonesia. We do the application of the zirconia. And last session, I will share you about the, well, this is just to share you about the transportation development of BPPT. I try to use the hydrogen mobile, yeah, when I visit Tanaka Kikingzoku, I use the Clarity, and I also use Mirai. And we know that this transportation would be a challenge to make an implementation of the hydrogen in transport in vehicle. Next slide. We know that Jakarta, you can see Jakarta air pollution is very high. And during the pandemic, maybe 1 year ago, yeah, 1 year ago, we know that Jakarta has a different sky. The left one is annual Jakarta sky, but during the pandemic, we know that Jakarta have a blue sky suddenly because all of the transportation is stopped. And we can see that if we change the transportation, the pollution is going down. Well, BPPT and others university make a development of the fuel cell motorcycle. This is a prototype, but we create this in 2009. But until this day, it's still running. And we make a calculation of hydrogen consumption as 1 liter per kilometer. Next one, we try to have the, you can try it at Serpong. This is our like scuba, yeah, scuba valley. This is the research facility of BPPT and LIPI and Batan and so on. We also developing the mini car of fuel cell. We use a PEM-FC, next please, PEM-FC of 1 kilowatt. This mobile vehicle also now have been used around surrounding our facility. And this fuel cell car is modified from the electric car. And we putting the 1 kilowatt of fuel cells coordinated with a battery. And then now we're developing also a combination of photovoltaic in the golf car. This prototype to show the student, to show the government relation, what we can do with the transportation that have no emission. So BPPT also focus on the electric vehicle implementation, especially for making a charging station. We have also the conversion of EV to FCV. Yeah. Dr. Dadang also mentioned about the application of fuel cells on the base station. We are also have a collaboration with PT Kaskadian in Indonesia since 2017, and we make a collaboration to doing testing for the implemented fuel cells in the remote area, and then we doing the repair of the fuel cells and so back it to the industry. So this is our last slide about our idea how to make the hydrogen city also in Indonesia. If we can make this pilot, we can show about the reducing of the emission. So if we go, west side of Indonesia is Sumatra Island. We know that Sumatra Island have many gas and many palm industry. So why if we make a hydrogen highway in that tall highway of Sumatra? But this is just our idea, but not have been implemented yet. We must talk about this to the Ministry of Industry, also supporting by many stakeholders. So how we can achieve the 40% carbon neutrality by 2030 and net zero by 2070. So this is the target of the Indonesia. I think we must stop build the new coal power generation by 2025. And then Indonesia should push down the CO2 emission from the transportation sector and also power generation. And we want industry in Indonesia have to make a green hydrogen implementation and also carbon capture implementation in many chemical industry. And we know that Indonesia need more hydrogen in industrial application. As we know that a biodiesel B30 program has been accelerated, they need the hydrogen. And also methanol production, they also need the hydrogen. And the growth of the chemical industry is significantly increased, so they also need a hydrogen. So we want to, they use the green hydrogen. So thank you for this opportunity, the time, and we welcome to the discussion, and also please join us in the WWIFHE or ID. We have a big collaboration association here. We have also industrial members, also the researcher, and also a student. We have more 100 members right now. We still welcome for others. So thank you. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Enia Listiani Dewi, for the presentation. So next up, we have Dr. Muhammad Abdullah bin Zaidel to do his presentation. Dr. Muhammad Abdullah bin Zaidel is a Director of Economic Planning Unit Sarawak, the Sarawak Chief Minister Department. He was a Senior Finance Lecturer at the Faculty of Economic and Business, University Malaysia, Sarawak. He is also a Harvard Business School alumni, additionally associate. Professor Dr. Muhammad Abdullah is a member of the Special Interest Group on Hydrogen Economy at the Academy of Science Malaysia. Okay, so I would like to welcome Dr. Muhammad Abdullah bin Zaidel to our screen. Dr. Muhammad Abdullah bin Zaidel, time and screen are yours.
Okay, thank you very much, MC, and Assalamualaikum and good morning to everybody. Today, basically, I'm very grateful to Nando for giving me the opportunity to share some of the states of Sarawak, part of a state in Malaysia, and on Sarawak hydrogen economy vision. All right, okay, next please. Next, okay. Sarawak basically is one of those earlier to explore hydrogen economy, and we have a Sarawak hydrogen economy vision of 2030, of which we aspire to produce green hydrogen via renewable sources where minimal impact to the environment. So if Sarawak is also the first in Southeast Asia in this region, basically to promote hydrogen economy in a very applied way. But I believe, as what the professor from Indonesia just now reflect, they have started in 2009. And again, we feel that it is an honor for us to be part of the hydrogen economy development in this region. So the application of hydrogen across a range of industrial process are basically shown here lah. So basically, we believe that global market for hydrogen is expected to reach USD 196 billion by the year 2030, of which Sarawak would like to be part of the development. Okay, next. This is a picture of our post-COVID exit strategy, our economy post-COVID strategy, of which we have various sector that we are looking at, and one of the main sector that we wish to highlight here is the renewable energy. There is the what they call fuel of the future, we call it. So among others, we have agriculture, commercial agriculture. In order to transform our economy to a developed state, we have our as shown here, we have commercial agriculture, data center and innovation, infrastructure, manufacturing and entrepreneurship, mining, education and human capital development, forestry, tourism services, but more importantly is the renewable energy. Next, please. By 2030, Sarawak will be expected to be a thriving society driven by data and innovation, where everyone enjoy economic prosperity, social inclusivity, and sustainable environment. So the key word here that our economy by the year 2030 is basically based on three main pillars, which is the economic prosperity, inclusive society, and environmental sustainability, of which all these three pillars are driven by data and innovation. What I wish to highlight here is that the emphasis on environmental sustainability. Next, please. To achieve this high income status by the year 2030, which is 10 years from now, Sarawak needs to grow at an average of about 8% GDP per annum. If we were to do business as usual, we will only grow at about 3.4%. But for us to achieve a developed state by the year 2030, we need to grow at least 8% GDP, of which we need to have to achieve a 282 billion GDP by the year 2030 in terms of our annual income. The next, please. Our mission statement is to reduce petroleum use, greenhouse gas emission, and air pollution, and to contribute to a more diverse and efficient energy infrastructure by enabling the widespread use of commercialization of hydrogen and fuel cell technology. This is our mission towards 2030. This is the state mission towards 2030. Yeah, next slide, please. I'd like next to talk about the framework of how we want to achieve this vision by the year 2030. To be the forerunner for green hydrogen economy in Southeast Asia. As many speakers highlighted earlier, you're talking about hydrogen, but Sarawak only emphasize on green hydrogen. The target will be the forerunner for green hydrogen. How are we going to achieve this? We believe that there must be very important policy supports by the government, the political will, and of which we have it now. And then the infrastructure development, what leads towards development of this hydrogen economy. And of course, we need the human capital, the people behind it, meaning to say we need to focus on the education and capacity building as well. We need to get the buy-in from the people of Sarawak and Malaysia in general on the idea of hydrogen economy. So this will be supported by 5 pillars, namely production and storage, transportation, commercialization, application, research and development. With this, Sarawak hydrogen will be able to be achieved by the year 2030. So to be a forerunner for the green hydrogen economy in Southeast Asia, that is our aspiration, our mission, our aspiration to be one of the main player in Southeast Asia. Next, please. So to embark on this mission that we have, Sarawak have established the enablers. namely policy support. Sarawak government give its support and craft policy which will encourage and promote the green hydrogen agenda. As I described earlier, the political will is there, so the government is fully behind it to support the effort of hydrogen economy. Secondly, the infrastructure development to encourage private sector investment in the building of its new infrastructure. In the early stage, subsidized and any other financial support would be required. And thirdly, we need to educate the people to embrace the idea of green hydrogen economy. For capacity building, we should have a dedicated training and development center to cater to developing our talent in the new fields. So these are the enablers. So strong public-private synergy to develop these pillars. These pillars will only happen if there is a strong collaboration between the public and the private sector. So providing a focused, structured, and holistic approach to advance in the green hydrogen economy of Sarawak. First is the production and storage, producing hydrogen via renewable energy source and with competitive costs. Sarawak is known to have 5 big hydro dams available that produce renewable energy every day. And at the same time, in terms of transportation, optimizing the cost of transportation of hydrogen for domestic use and export market. This is where we need to address. We need to address the cost factor of transportation of hydrogen for both domestic and for export market. Commercialization as exploring potential market for green hydrogen in the region and beyond. So all this is based on commercialization. And of course, the application to upscale the usage of green hydrogen and hydrogen fuel cell in transport sector and other industries. And finally, the last pillars is the R&D. Increasing R&D effort to improve the efficiency of hydrogen-related equipment. For example, fuel cell, electrolyzer, etc. And the cost optimization of a green hydrogen economy. Okay, next. I like also to mention on the roadmaps that we have. Here, if you look at the timeline, we are at the 2021. So we have started this initiative early 2017, 2018, but more aggressive outcome you see in 2020 last year, and more to come this year. And if you look at these roadmaps that we have, for policy support, inclusion of hydrogen as part of the energy transition plan in the National Energy Policy 2020 to 2040. And if everybody take note that, you know, in the last year budget presentation by the Minister of Finance of Malaysia, he did give a special allocation for importation of hydrogen commercial vehicle with tax exemption for Malaysia. So for importation of commercial vehicle powered by hydrogen were given special tax exemption. So which I believe this is already indicative of the national energy policy. And government grant, subsidies and tax incentive to encourage the growth of hydrogen economy. And then also adaptation of hydrogen safety standard and regulation. So these are already in the pipelines. I believe Professor Dato' Wan can confirm this later on as our next speaker. And on the infrastructure development, encourage private sector investment in hydrogen infrastructure investment, which I'm going to highlight afterward, some of the things that have been done. And then government grant in early stage would be required for infra development. Of course, this, for example, the setting up of hydrogen kiosk, the 3-in-1, and also the setting up of hydrogen refueling station and hydrogen production, commercial production by the year 2023. So all these have been clearly spelled in our timeline in terms of all these enablers that I have mentioned earlier, including education and capacity building, production and storage, transportation, commercialization, application, and R&D. So these are what have been done and will be carried out and in the very near future. Next, please. Overview of our project that we have which already on the ground. Sumitomo Corporation and Sarawak Economic Development Corporation have entered into a MOU in November 2019, initiating a feasible study to join develop a commercial scale green hydrogen plant in SEDC Kidurong Petrochemical Park in Bintulu. As is shown in the map there, the location of Bintulu, there is already work done on the ground, and INOS, another Japanese giant, joined the consortium in October 2020, bringing along its expertise and technology in hydrogen transportation. And this project, called Project 2 Hornbill, targets to commence operation of a 25 megawatt or 3,000 ton per year capacity plant by the year 2030, and to scale up to 75 megawatt or 10,000 ton per year capacity by the year 2025. The land area earmarked for this project has the capability to scale up to 700 megawatt or 100,000 tons per year capacity. So shipment of the green hydrogen produced to Japan will be utilizing INOS MCH technology. So these are another collaboration that you see have been on the ground and hopefully to be realized by the year 2023. And finally, I'm looking at the upcoming hydrogen related project in Sarawak, just to share. There is a vast potential of growth from this upcoming project planned for now until 2030. As for Kuching, the capital city of Sarawak, we have this Kuching ART, which is already now being executed on its basic infrastructure, and then hopefully to be rolled out by the year 2023. And also hydrogen production plant, the one that I have mentioned earlier, the 100 to 700 megawatt plants in Tanjung Kidurong, Bintulu. And of course, the potential, which is still at a very high level, a regional hub for aviation, especially hydrogen. And we are talking to Airbus to potentially relocate or locate their hydrogen R&D to Sarawak, because Sarawak have a huge potential in hydrogen development, especially in terms of its basic resources, the renewable energy, which is very cheap, looking at almost about 5 cents US, per kilowatt hour in terms of energy. And of course, in terms of what we call stability of the geography, we are outside the ring of fire. There is no earthquake. There is no what we call flood and all this catastrophic environment. The state is blessed with that. And on top of that, we have a very stable politic and supportive government in this initiative. So these are some of the points that I wish to highlight that Sarawak have advantage in terms of its hydrogen aspiration. Next is the multi-fuel station, which should be the first one to be up and running by June this year, and it's under construction now. And first multi-fuel station in the country, I believe, which include EV and hydrogen refueling station. And of course, the next in line is the aspiration of the government to have government agencies hydrogen fleets. Should we able to access to some of current what they call hydrogen powered vehicle. Okay, next. Next slide, please. Building a hydrogen ecosystem in Sarawak requires participation from various parties. As I said earlier, it can only work if there is a collaboration between private and public sectors. So in this case, hydrogen industry players needs to work together with the state in order for us to achieve this aspiration. So in the case of Sarawak hydrogen ecosystem, we have SEB, Sarawak Energy Berhad, that provide the renewable energy, the green energy at a very competitive and so far the cheapest in this region. SEB, Sarawak Energy Berhad, the electricity company, can supply renewable energy at a very cheap cost and the cheapest in Southeast Asia in terms of rates. And then we have industry player, and we have at the moment SEDC Energy, which is one of state GLC, to lead this venture of hydrogen economy. And of course, the R&D, which include JICA, UNIMAS, and many other education institutions. And we also need international conferences. And we have already event managers and event conferences available in Sarawak. And finally, Hydrogen Society and Association. So we need to link up to this association, of which, as mentioned, I'm one of the members of the association. Okay, next. For that, I have concluded my presentation for this, and I'm happy to explore more opportunity for the development of hydrogen economy in this region. And I believe that with this our participation, the state government participation in this webinar will give some insights to those who are interested to work on this hydrogen investment in Sarawak are very much welcome, and we hope that this will bring for the betterment of human living throughout the world. With that, I pass back my my time to MC.
Thank you, Dr. Muhammad Abdullah bin Zaidal, for your presentation. So next up, we have Professor Dato Insinyur Dr. Wan Ramli Wan Daud. Professor Dr. Insinyur Dr. Wan Ramli Wan Daud is a professor at National University of Malaysia and founding president of Malaysian Association of Hydrogen Energy. He got his PhD degree from University of Cambridge, United Kingdom, in chemical engineering in 1984. He also a founding director in Fuel Cell Institute UKM. So, Professor Dato Insinyur Dr. Wan Ramli Wan Daud, time and screen are yours. Okay, Professor Dr. Insinyur Dr. Wan Ramli Wan Daud, I think you still muted your microphone. Yeah.
Sorry about that.
It's
yes,
okay.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning, everyone. First of all, I would like to thank NEDO for inviting me to give some thoughts on the hydrogen trend in Malaysia. I would like to share the PowerPoint. I seem to have a problem.
Should we provide the presentation from our side, Professor?
Hang on, I couldn't find the. I couldn't find the window. Where is it? Sorry, I'll have to go to, have to reopen.
Okay.
All right, can everyone see it?
Yeah, it's still processing, I think.
So, yes, I would like to thank NEDO for giving me the opportunity to speak on the hydrogen energy trends in Malaysia. But for the benefit of the audience who may not be familiar with the issues of why we need hydrogen, I would like to have a brief discussion on the two challenges of the world. One is energy security, and the other is climate change. And as we know, world energy supply is now nearly 600. Hello, what's happening?
So is it okay if we use by our side? This is your presentation materials. Is it?
I thought I've already shared my presentation.
Yes, okay. It's still not appearing.
Yeah. It should be there by now.
Okay, now it's okay. Thank you very much.
Yeah,
Please
all right.
continue. Okay, thank you.
Right. I shall continue with the presentation. The world energy supply is nearly 600 gigajoule, and consumption is about 400 gigajoule, and about 80 to 90% of the total energy is from fossil fuel, and fossil fuel reserve depleting, and production is peaking. Yeah, that means it has reached its maximum production rate and will be declining in the coming years. So there is the issue of getting the enough energy to fuel the economy. The other problem in the world is, of course, climate change caused by global warming and carbon emission. In 2015, I think the world leaders have met in Paris to sign an agreement called the COP21 in Paris Agreement, in which they all are committed to strengthen global response to keep temperature rise below 2 degrees C. And you can see the effect if you continue not to act or business as usual. You can see the top red line will go on increasing, and that would cause a catastrophic climate to the world. Yeah. So if you keep the temperature below 2 degrees C, and you can see that the green line, that should be the ideal pathway in which the world could try to reduce carbon emission and to prevent climate disaster in the future. So most countries diversify their fuel sources with low zero emission energy, renewable, such as biomass, biofuel, solar energy, and wind energy, and of course, green hydrogen energy and nuclear energy. But nuclear has some issues, as everyone has seen in the Fukushima disaster and so on. And many of the countries also developed their green technology, including low or zero emission clean energy technology. And you can see that in the future, there will be a lot more renewable energy being used in electrical generation, yeah, in the future, and there will be no more oil being used for electricity generation, and the single energy sector that grows would be the renewable energy. As you can see at the top, it's growing at quite a fast rate. So that's what the world is wants to do. And if you look at the renewable energy of the world, and it's increasing, a lot of hydro, and then wind and solar is also increasing, and bioenergy a little bit more at the top. So what is Malaysia going to do? Well, at the COP21 Paris Agreement, Malaysia is committed to cut carbon emission intensity by 40% of 2005 level by 2035. And in meeting the target, Malaysia will continue energy efficiency effort and conservation as well, and also to increase the renewable energy in the energy mix to about 20% by 2030, and to encourage electric vehicle in the transportation sector. But the problem with electric vehicle, the electricity produced is still emitting carbon dioxide. So it's not it's a partial solution, yeah. If the electricity is still mainly produced from fossil fuel, so you need to actually increase RE target as well as the deployment of electric vehicle. So hydrogen could be used as the sixth energy or sixth fuel, as it's called in Malaysia, in our energy mix. So at the moment, our energy mix, there are 5 fuel, yeah, and the 5th fuel is renewable energy. And so if we were to integrate into the national energy policy, it has to be as the 6th energy in the total energy mix. In the transportation sector, maybe there's some opportunity to introduce green hydrogen fuel cell vehicle together with the electric vehicle that are already being planned. So we'll look at the evolution of Malaysian energy policy. In 1974, when we found that we had a lot of oil, so we need to have an act to regulate the oil industry. Before this act, both ESSO, or now Exxon, and Shell had found oil in Malaysia, and they had there is no proper regulation, national regulation to exploit the oil for the nation. So the Petroleum Development Act gave the government or Petronas to actually acquire all the oil wells, yeah, and then to sign a profit sharing agreement with all the oil companies. And in 1975, we formulate the National Petroleum Policy. And when there was in 1979, when there was the Iran-Iraq war, and this issue of oil security, we developed the National Energy Policy and the National Depletion Policy in 1980, yeah, so that we could conserve our oil. And because of the problem with the war, we then developed, we diversify our fuel for electricity generation, and we have this 4 fuel diversification policy in 1981. And the 4 fuel are petroleum, natural gas, coal, and hydro. It's only in 2001 that the government of Malaysia recognized the need to introduce renewable energy in the energy mix. And so in 2001, we have the renewable energy as one of the 5th fuel mix. Yeah, hydro is a renewable energy, but in the parlance of the energy ministry, renewable energy is other than hydro, but it's also include mini hydro, micro hydro as well. And we kickstart the renewable energy policy by having the small renewable energy power, yeah? And the mainly solar energy and biomass. And then in 2006, the Ministry of Energy commissioned the Energy Center Malaysia, which is now called the Green Tech Corporation. It has been changed recently to Malaysian Green Tech Center, Green Tech and Climate Change Center, sorry. A roadmap for solar, hydrogen, and fuel cell, yeah, in 2006. Now, this roadmap shows the pathway in which Malaysia should take to develop the solar energy, hydrogen energy, and fuel cell in the future. And the program in the roadmap was employed in the 9th Malaysia Plan, but in subsequent Malaysia Plan, it was neglected by successive Malaysian government because of other priorities. In 2006 also, Malaysia had developed the national biofuel policy, that is to introduce biofuel at the pump station, B5, B10, and B20. Also by 2010, there is another roadmap that consolidates the solar, wind, and biomass, yeah, into one roadmap, and that's called the Renewable Energy Roadmap. Unfortunately, hydrogen was not part of this renewable energy roadmap, and somehow it was neglected. And as a result of the roadmap, the Malaysian Parliament approved the Renewable Energy Act in 2011, as well as the SEDA Act. SEDA is the vehicle to implement the feed-in tariff for renewable energy. Yeah, SEDA is the Sustainable Energy Development Authority. And in 2017, the Academy of Science Malaysia had revised the 2006 roadmap since it was not being implemented beyond the 9th Malaysia Plan. So the Academy had revised the roadmap and had proposed a new one, which we are now proposing to the government of Malaysia. The FIT for renewable energy deployed by SEDA ended in 2016, and the Energy Commission had taken over and had introduced net energy metering, yeah, and in 2017 followed by large-scale solar, yeah, of 100 megawatt and above. So it has already been deployed, and the target is 20% by 2035. And in the new roadmap by the Academy, we want to suggest that hydrogen should be the sixth fuel, which should complement the renewable energy as well. And Malaysia government is also deploying policies for electric vehicle for transportation. But as I said, the electrical power still emit carbon. So it is not solving the problem, but only partial part of the problem. So we're going to us for the transition to green hydrogen fuel cell vehicle as well in the future. So in the future scenario, it's not replacing fossil fuel with renewable energy, but there will be a portfolio of energy. I mean, fossil energy would still be dominant for a lot more years, but it should be replaced slowly by renewable energy and alternative energy such as hydrogen. And of course, as you can see, each form of energy has its own advantages as well as disadvantages. And that's why no one source of energy would replace all the rest. So there will still be a portfolio of this. Now, the idea is to replace the economy
Excuse me, Professor Wan Ramli, can you hear us? Can you hear my voice? Seems there's some technical problem with Professor Wan Ramli. Can you connect with us?
Yeah,
Okay.
There's a slight problem.
Okay.
So to replace the economy based on fossil fuel, so the red lines are all fossil fuel, and the and gas, the light blue line, and very few renewable energy. You can see only one windmill and solar, right? So is to transform to an economy where it is based on electricity from renewable energy and fuel from hydrogen. So you can see here the solid blue line, those are electricity from renewable energy. There are a lot more renewable energy.
I'm so sorry, Professor Dato Insinyur Dr. Wan Ramli Wandaud.
Yeah.
We cannot see the presentation, so is there anything we can help to share the presentation to you?
I will reshare, please. I will
Okay.
reshare. Sorry, there was some problem with
Okay, now we can see it. Thank you.
So is to transform this fossil fuel-based economy into one that is based on electricity from renewable resources, wind and solar and so on, and on hydrogen fuel. As you can see here on the right, the solid blue line, these are the electricity, and the light blue flame, and that's the hydrogen. Yeah. So it is a transition or transformation from a fossil fuel-based economy to one on renewable electricity and renewable or green hydrogen. So this is the hydrogen economy, of course. For the audience who are not familiar with hydrogen economy, it's a type of circular economy where hydrogen is produced from renewable resources, from splitting of water using electricity from solar power or from hydro or from wind energy to produce hydrogen. And hydrogen is an energy carrier, and it could be applied or used in various industrial sectors. in power generation industry, as well as in transportation. And the net product of the application of hydrogen is water, which could be recycled back through the to the splitting of the water into hydrogen by renewable energy sources. So it's a kind of circular economy, and this is a very good thing for the world. In Malaysia, most of the R&D on fuel cell and hydrogen energy is done at the Fuel Cell Institute in University Kebangsaan Malaysia, Cell Fuel, established 16 years ago, and I have a 20-year research history. This is very important because we need, Malaysia need to have the R&D expertise in hydrogen and fuel cell in-house so that it could accelerate the implementation of hydrogen. And this is the institute at UKM Malaysia. The first 3 directors, I was the founding director. At the same time, we also need an advocacy association, hydrogen advocacy association that would campaign to with both government and the public for the adoption of hydrogen energy in Malaysia. And I'm also the founding president of the Malaysian Association of Hydrogen Energy. And we had also relation with the Indonesian IJFE as well as the International Association of Hydrogen Energy. And we have international networking all over the world for R&D in fuel cell and hydrogen energy, including Japan, including Japan. And the main research group in the institute as well as in Malaysia is first, of course, the fuel cell electrochemical processes that included the electrodes, the membranes, and the membrane electrode assemblies of PEM as well as other fuel cell. There's also a group of process system engineering and bipolar plate material. This group developed prototypes for fuel cell and fuel cell application, like the fuel cell buggy and motorcycle. And there is also a lot of research activity on solid oxide fuel cell, mainly in the development of low temperature solid oxide fuel cell material. And there's also a big group on direct micro fuel cell, mainly for application as a charger for mobile phones and laptops and so on. Also, we have a group on biohydrogen and microbial fuel cell. You can actually produce electricity from wastewater directly instead of converting to hydrogen and then using the hydrogen to produce electricity. You can actually produce electricity from microbial fuel cell directly. And a foot in the future is the solar hydrogen group, where they develop a photoelectrochemical cell. This is the holy grail of hydrogen energy, where you could produce hydrogen in one step using solar energy in a single equipment called the photoelectrochemical cell. And lastly, of course, we also developed technology to convert primary fuel into hydrogen energy. And these are some of the products from R&D in Malaysia, prototype fuel cell power generators for portable power, fuel cell powered motorcycle. And these are all in the early 21st century, 2002, 2005. And then this is the education kit that we developed, and we are in the process of commercializing it and using it in STEM activities. Mobile phone charger. Yeah, this is an early prototype in and a smaller and sleeker version will be produced by a company. We also developed several fuel cell powered vehicle. Yeah, in this picture you can see Tun Mahathir riding with me in the fuel cell. So we developed also a fuel cell buggy for big companies, large companies that have R&D collaboration with us in hydrogen energy. And we also have developed a PEM electrolyzer, and we are also now developing an AEM electrolyzer for another client. This is a short video just to
Professor Wan Ramli, I'm
Yes,
so sorry to remind you that we don't have
yeah, we're going to finish
the
soon.
time. Yes, okay.
So there'll be the supply chain at the moment is only blue hydrogen from fossil fuel without CCS, carbon capture and storage, or carbon capture and utilization. But at the moment, countries are considering gray hydrogen, where carbon dioxide is being captured, stored, and also utilized. And of course, the development of these supply chains is very important to solve the problem of supplying the hydrogen to the application. And several large demo projects in Europe and Japan, and also in the US, Korea, and China have done some demonstration project on the supply chain in order to solve some of the problem in supplying hydrogen to the. In the future, hydrogen is to be produced from renewable energy resources and from biomass, wave, solar, and wind energy. And there's another new one called the ocean thermal energy conversion. If you have a very deep trench, Malaysia have one, a deep ocean trench, you could develop or you could use ocean thermal energy to convert into electricity and then to produce hydrogen by electrolysis. And at the bottom is the photoelectrochemical cell, which would produce the hydrogen in one single cell. And of course, we have zero emission. Now, the other challenge is the cost of production. Yeah, if you look in 2099 from ARENA, you can see that some of the costs for one kilogram of 1 kilogram of hydrogen. And here at the end here, you can see that the cost is around $2, nearly $2, yeah? With the carbon capture and storage, yeah? $3 per kilogram, and in biomass as well. So this two is now currently the cheapest, but in the future the cost by solar energy is going down. Yeah, and you can see this. The cost of electricity from RE is going down. So I think all over the world, people are looking at both solar, and in places where you have wind energy and biomass energy is now falling to fossil fuel price range. So hydrogen production from biomass and water electrolysis by cheap renewable energy are economic now because of low cost of biomass and solar PV, as well as from wind energy. So in Malaysia, we have a lot of renewable energy resources, and you can see one place, which is Sarawak. We have a pilot project, and this has been said by the previous speaker, where you use hydropower to produce hydrogen and use it in a public transportation project. So there are plenty of renewable resources in Malaysia that we could use for green energy. And in the
excuse me, Professor Wan Ramli, excuse me. I would like to remind you about the time. We really
we're finishing soon. Yeah.
Okay, thank you very much.
This is the original roadmap, where actually we were supposed to have the demo project in 2009 and 2010, but this is at the end of the 9th Malaysia Plan. But the government of Malaysia didn't continue the roadmap. The same way for the fuel cell roadmap as well. You can see that the demo project is supposed to be in 2020 but it wasn't implemented. So in 2017, the Academy of Science Malaysia updated that roadmap. We are now working on this and trying to convince the government to adopt this roadmap. And you can see that the pilot demo project would be in 2025 onward, yeah, because we have to start from back to square one, where we work on codes and standard public awareness policies to support hydrogen infrastructure and so on. And we are now in discussion with the National Economic Planning Unit. This afternoon, we will be presenting this to them, and we will try to get them to adopt this roadmap. And of course, hydrogen supply to Japan, I think, is being planned by Australia, Norway, yeah, and also Brunei. I think has been the pilot project is already going on, and in Malaysia, there's a possibility of supplying hydrogen to Japan by two methods. But I think the one that people are looking at is by using either ammonia or MCH, yeah, like the one that has been discussed by the previous speaker. Petronas vision, yeah, that was shared with us. In the short term, hydrogen is used as a decarbonization solution, yeah. So management of carbon dioxide emission across Petronas value chain via carbon dioxide conversion by hydrogen. So, and development of indigenous green hydrogen production technology with UKM Fuel Cell Institute. But in the medium and long term, hydrogen enable potential business growth. One of this is green hydrogen as clean fuel for power generation and transportation using UKM technology, among others, and could be sold to Japan in the near future. The national utility company, the largest utility company in the country, also have a hydrogen roadmap, but they are also looking at decarbonization instead of using it as a fuel. But in the long term, as you can see, way forward, hydrogen application for energy storage and hydrogen for portable power generation. So these are the two large companies in Malaysia who are doing a lot on hydrogen. And then, of course, the Sarawak project. I had the opportunity of riding the car, the Hyundai car, the Sarawak SEDC let me drive it at the launch. Yeah. So this is a Hyundai Nexa car. So I think Sarawak is a place where hydrogen economy will thrive because the political leadership have bought the idea. In fact, the chief minister is the one who drove the adoption of hydrogen in the state. So, and these are their plan. I think that has been introduced by the previous speaker. And so thank you very much.
Thank you very much, Professor Dato Insinyur Dr. Wan Ramli Wandaud, for your presentation. So, ladies and gentlemen, we are going to continue to the second session of the webinar presentation. So there will be no break until we reach the end of the webinar sessions. And also welcome to everyone who has joined us. Welcome to the Future Outlook for Hydrogen Energy in Southeast Asia, featuring Indonesia and Malaysia webinar. So for this topic, for our second sessions, is about introduction of Japanese hydrogen energy solutions. And there will be 4 speakers for this session, which are Dr. Motohiko Nishimura from Kawasaki Heavy Industry. And then we have Mr. Satoshi Tanimura from Mitsubishi Heavy Industry. And then we have Mr. Shinji Kondo from Sumitomo Corporation. And also we have Mr. Masaki Sakamoto from Yamanashi Prefectural Enterprise Bureau. So the first speaker who will represent his material is Dr. Motohiko Nishimura. Dr. Motohiko Nishimura is an
Yes.
executive.
Can you hear me?
Yes, we can hear you.
Okay. Could you let me share my display?
Okay.
Okay.
Okay, so our team will
Could you see the
like
material?
Yes, we can see it.
Okay, here we go. Thank you very much for your kind introduction. My name is Motohiko Nishimura of Kawasaki Heavy Industry. First of all, I'd like to express my gratitude to make a presentation on this program. And daily, we have support from NEDO and METI Japanese government, and also the, from support from the Australian government. We really appreciate about that. So while you may associate Kawasaki with motorcycles, we have a broad spectrum of technologies for energy and transportation, equipment such as ships, aerospace, rolling stocks, distributed power generation systems, precision machinery, and robots. By applying such technologies, we have been developing products that are necessary for realization of hydrogen energy supply chain, ranging from hydrogen production to transportation, storage, and utilization. Currently, the world is moving toward decarbonization, and mass hydrogen utilization has been highlighted. This is because energy system only with renewable and battery storage has a limit for energy scale, facility cost, and applications. Liquefied hydrogen, which Kawasaki is promoting, enables large amount long-distance, long-term transportation and storage of energy and connects multiple sectors. Also, extremely wide range of industries are involved in hydrogen supply chain and demand field, which create a virtuous cycle for environment and economy. Kawasaki aims to contribute to achievement of decarbonization as a solo company in the world that owns the full supply chain technology for production, transportation, storage, and utilization. Kawasaki is one of the founding members of Hydrogen Council, launched at the World Economic Forum 2017 in Davos. Hydrogen Council is a global initiative of leading companies with a united vision and long-term ambition for hydrogen to foster the energy transition. The council, which started with 13 companies, has now grown to include 109 companies and is working vigorously to promote the deployment of hydrogen and expand the hydrogen market. Hydrogen Council has shown the Hydrogen Introduction Vision 2050 in their report. According to the report, hydrogen market will scale up to $2.5 trillion and create 30 million employment in 2050. Also, hydrogen would meet 18 of total final energy demand. Thus, hydrogen has a big potential and could be the next game changer in the energy system. Kawasaki is working to establish hydrogen energy value chain to supply hydrogen stably, affordably, and safely to Japan. This slide shows potential of carbon dioxide-free hydrogen supply chain to Japan. Hydrogen can be produced from various sources and may enhance the energy security of Japan. We are discussing with many stakeholders to realize hydrogen supply chain. From the perspective of cost and energy security, we are focusing on Australia, which has abundant resources and the voyage route is safe. And this is a concept of international hydrogen supply chain that Kawasaki is promoting. We are aiming to develop hydrogen supply chain producing hydrogen overseas from affordable resources and transporting to Japan in the form of liquefied hydrogen. We have selected liquefied hydrogen as an energy carrier, hydrogen carrier. This is because liquefied hydrogen is non-toxic and clean. It is also highly pure and can be supplied directly to fuel cells after evaporation. Therefore, it doesn't consume energy when it is utilized in Japan. We believe that a viable transition pathway to a green hydrogen industry will be to focus on production of hydrogen at scale using fossil fuel and CCS technology, allowing green technologies to scale and become economically viable over time. Kawasaki is working together with partners in a pilot demonstration project to establish an international hydrogen supply chain between Australia and Japan, targeting its commercialization. In order to deliver environmentally sustainable hydrogen energy, carbon dioxide produced as a byproduct of the process must be captured and sequestrated under the ground or under seafloor. This means a key element to the project is carbon capture and storage, CCS. Australia is one of the most advanced countries in terms of CCS. In Victoria, CarbonNet, a CCS project, is being promoted jointly by the Australian and Victorian governments. We are collaborating with CarbonNet project and will leverage CarbonNet CCS infrastructure, as the hydrogen supply chain project is the most likely foundation customer of the CarbonNet project. Some of you may be concerned about the life cycle carbon dioxide emissions of coal-derived hydrogen supply chain. Therefore, I will introduce life cycle assessment reported by Mizuho Information and Research Institute. This figure shows well-to-tank carbon dioxide emissions in each hydrogen production from renewable energies and the Australian brown coal. In case of using brown coal, CCS, brown coal is referred as lignite in this figure. So in case of using lignite, CCS is engaged. According to this study, carbon dioxide emission of liquefied hydrogen made from lignite with CCS is comparable to that of other renewable originated hydrogen. This slide shows structure of a pilot hydrogen supply chain between Australia and Japan. The pilot project will be demonstrate coal gasification and hydrogen refining at Lateral Valley in Australia. Hydrogen liquefaction and storage of liquefied hydrogen at Hastings, maritime transportation of liquefied hydrogen from Australia to Japan, and unloading of liquefied hydrogen in Japan, Kobe, in 2021, this year. The pilot demonstration project is divided into two portions and is being promoted by two organizations, Hystra and HEA, respectively. Hystra is in charge of blue-colored rectangular portion, including hydrogen production from Victorian coal, maritime transportation of liquefied hydrogen by ship and receiving terminal in Japan, and of which have technical hurdles of overcome. All of which have technical hurdles to overcome. On the other hand, HEA is in charge of the orange-colored rectangular portion, including hydrogen refining, land transportation, liquefaction, and export terminal. This portion will play an important role in getting social license for hydrogen in Australia. So hydrogen gas production via the gasification of Victorian coal has been started in Lateral Valley The plant is constructed and operated by J-Power, while J-Power applies their own coal gasification technology, which has already been attained commercial scale for bituminous coals. The project members announced the commencement of operations at both Victorian States, Lateral Valley, and Hastings Port of its world first integrated supply chain on 12 March 2021. The site in Hastings Port is shown in the next slide. That's it. So this picture shows the hydrogen liquefaction site in Port of Hastings. Pressurized hydrogen is transported from Lateral Valley by a truck and fed to liquefaction plant that cools hydrogen down to minus 253 degrees centigrade. Liquefied hydrogen is transferred to a cryogenic container trailer. The container trailer goes to the jetty nearby, and then the liquefied hydrogen is loaded onto the hydrogen carrier ship shown in the next slide. Please see this. So this is a computer graphic of the liquefied hydrogen carrier called Suiso Frontier, developed and used in the pilot project. This carrier has been constructed in our Kobe works. Its cargo tank has a double wall structure with vacuum gap in between to prevent evaporation of liquefied hydrogen. This 1,250 cubic meters tank could transport 75 tons of liquefied hydrogen in one voyage. And this is a real photo of the ship. So please show left-hand side bottom. The launching ceremony of Swiss Frontier was held December in 2019. And please look at the right-hand side bottom. In March 2020, the cargo tank was mounted and installed on the ship successfully. The tank diameter is 10.5 meters and length is 24 meters. With such a large dimensions, although the installation accuracy in lateral and longitudinal directions are several millimeters, very precise installation. Sea trials are ongoing since last October. The first delivery of liquefied hydrogen from Australia to Japan is scheduled in this year. The construction of the liquefied hydrogen receiving terminal in Japan was also completed in May 2020 on the Kobe Airport artificial island. Currently, the trial run is progress. Ship-to-shore transfer of liquefied hydrogen using loading arm system will be demonstrated at this terminal for the first time in the world. So, looking back to the development of LNG equipment, it took a long time for scaling up, say something 20 or 30 years. But with our great deal of know-how for LNG and liquefied hydrogen equipment, and also with evolution of simulation technologies, we could accelerate the development of scaling up of liquefied hydrogen equipment. From 2019, we have started development of scaling up technologies. We are planning to develop 40,000 cubic meters of ship cargo tank and 50,000 cubic meters of onshore tank. Our partners are also developing other essential equipment for large-scale supply chain, for example, loading arm and pump. Okay, so Oshita-san also picked up this picture in his presentation. I would like to mention about the utilization of hydrogen energy. So, with regard to the hydrogen consuming facilities, we have been operating a hydrogen-fueled gas turbine cogeneration demonstration plant on Kobe Port Island since 2018, jointly with our partners. Our partners' names are shown in the red characters on the slide. This demonstration project aims to verify the feasibility of supplying both electricity and heat in a city area of the hydrogen gas turbine. So in the demonstration, the gas turbine uses 100% pure hydrogen as a fuel and supplies electricity and heat to the City Medical Center General Hospital, sewage treatment plant, International Exhibition Hall, and Sports Center, all located on the Kobe Port Island. This is a world-first project in the city area. Following successful demonstration of 0 to 100% flexible fuel technology with wet low NOx system, we announced successful technology verification of 100% hydrogen-fueled gas turbine operation with dry low NOx combustion technology, which has higher efficiency as compared to the wet low emission technology. So this slide shows about that dry low NOx emission technology and its combustor photograph. In July 2020, Kawasaki Heavy Industries and Obayashi Corporation, general contractor, have announced that a dry low NOx emission hydrogen gas turbine system has been developed. As shown in this picture, Kawasaki developed the micro mixed combustion technology. The technology verification test started in May last year. Was succeeded, and it was success in the world first case. The water injection method previously used to suppress NOx emission deteriorated electrical efficiency because of evaporation of water in the combustion. In comparison, use of the dry low NOx combustion method improves the electrical efficiency and NOx emission values at the same time. Okay, now I come to the conclusion. So I'd like to emphasize the importance of the carbon dioxide-free hydrogen supply chain for accomplishing decarbonization. Hydrogen from fossil sources such as natural gas, coal, etc., linked with CCS will realize vast energy supply. This contributes to stable energy supply and security. Moreover, hydrogen utilization emits no carbon dioxide. Thus, hydrogen is expected to play essential role in the decarbonization. Wide use of hydrogen brings industrial and economic growth. Lastly, hydrogen products started from fossil fuel will be shifted to the renewable energies in the future. This may realize sustainable energy society. Thank you very much for your attention. That's all I have to mention at this moment.
Thank you, Dr. Motohiko Nishimura, for your presentations. For our next speaker is Mr. Satoshi Tanimura. Mr. Satoshi Tanimura is a Chief Engineer, Senior Manager, New Energy X-Tech Department and Next Energy Business Division, Energy Systems at Mitsubishi Heavy Industry. So Mr. Satoshi Tanimura, screen and times are yours. Mr. Satoshi Tanimura, I think you still muted your microphone. We cannot hear your voice just yet. Is there anything we could do? Okay.
Can you hear me?
Yes, very clearly. Thank you.
Sorry about that. So thank you for introduction, and I'm appreciating the always NEDO supporting for the our hydrogen and ammonia project. Today I will introduce the hydrogen power generation to the beyond zero society. That means the hydrogen gas turbine and the ammonia gas turbines. 画像映ってる？カメラのオンオフ。これなんでオフなの？ やっと始まった。Sorry about that. So, okay, so today I will introduce our hydrogen gas turbine technologies. Then, so first of all, I will explain about our company itself. So, Mitsubishi Group has many hydrogen-related subsidiary companies, like offshore wind and compressor and iron making, and ammonia and ethanol capture, producing and CO2 capture. And so we have the space rocket technology. Mitsubishi Power is the core subsidiary company in the Mitsubishi Heavy Industries. Then we produce the power generating equipment. Then, sorry, then last November, MHI Group announced the energy transition scenario to the 2050s. So reducing the carbon CO2 and okay, and CO2 recovery. Oh, excuse me, someone has speaking that? No problem? Okay.
Yes, we will fix.
Then our energy transition has several steps of the in the scenario. And then today I introduced the established the hydrogen value chains. Then okay. Then this slide shows the how to say thermal power generation equipment zero carbon scenarios. Current thermal power plant using the many of the thermal power plant using the coals. Then a big effort is reducing the CO2 from such a coal plant, improving the efficiency and also the co-firing the CO2-free fuels like ammonia or biomass. Another thing is we developed the high efficiency natural gas firing gas turbine combined systems. Then finally, we are going to the hydrogen or ammonia using power plant. Of course, not only the big engines, so also we can apply the hydrogen SOFC. That is our final goal to the zero emission technologies for the power generation. And target date is 2030. So then we have several product for the power generation. One is boiler, coal-firing boiler. Then now we are testing the ammonia biomass coal-firing. The large frame gas turbine combined cycle, like 800 megawatts, large size gas turbines. Then 30% hydrogen co-firing is available now. Now we are developing the 100% firing combustor for this gas turbines. Then rate of the 2020s, we realize the ammonia cracking gas turbine combined cycle. Then on the other hand, the small gas turbine has a little bit different story. The small For the hydrogen, that is the same. 30% co-firing is the same. 100% firing also we can realize in the 2025. Then in small gas turbines, we can now we are developing the ammonia direct firing gas turbine. So that is a more simple system compared to the cracking systems. Then SOFC now we are developing the large size one, 1 megawatt size. Then so its two firings now under the development. Okay, so this is here from here I'll explain about the technology itself. Then so using the hydrogen gas turbine has some benefit for the hydrogen societies. The big one is the we can minimize the investment of the for the power plant. So hydrogen gas turbines, only difference of from the natural gas is the combustor portions. So that means current gas turbine user can convert the minimum cost to the hydrogen by the minimum cost. Then another thing is our gas turbines are huge. So hydrogen consumption itself is a huge amount. So it can help the infrastructure construction and the expanding. And then that helps also the hydrogen cost. Another good thing is so many hydrogen carriers needed in Japan. So not only the liquid hydrogen, another group considering using the MCH. Then some people considering the ammonia for the hydrogen carrier. In case of the gas turbine, we don't need the gas turbine. Don't need the pure. Don't need high purity hydrogen. Dirty hydrogen can available. That means we can cut the hydrogen purifying cost. And that can also help the cost reduction. Another thing is the gas turbine system has a very high demand response. That can help the renewable energy grid. So renewable energy is a little bit unstable. So hydrogen gas turbine can cover that supplying systems. That is those are the gas turbine, hydrogen gas turbines benefit for the user. Then just as I told you, the hydrogen gas turbines, only the difference is the combustor portion in the gas turbines. Then we have the three types of the combustor: diffusion types and the premix type and the multi-cluster types. Then, but our gas turbines, so designed for the retrofittable design, so we can change the switch the combustor in the service period. Then now we have three types of combustor. Then diffusion combustor is already available to use for the NOx hydrogen combustion. Our hydrogen-rich fuels experience started from the 1970s. So using for the cogeneration or especially for the petrochemical area cogeneration or IGCC area. The current natural gas turbine using this type of the dry NOx premix combustor. Premix combustor means the air and fuel mixed before the combustion. But the hydrogen has a high reaction rate. So the hydrogen content is limited in 30%. And then, but already this combustor was finished test and verification under the NEDO supporting. then this is available now. Then next type is the multi-cluster combustor, one of the premix type combustion. Then target is 100% hydrogen. Then now we are developing this combustor. The design target of the finish of the design is 2025. Okay. Then those combustors can be used in the all our line gas turbine lineup. So we have the small gas turbine, the 40 megawatts. Biggest one is 570 megawatts. So those gas turbine can use the hydrogen combustors. Then, of course, the co-firing and is available in all gas turbines. Then, in the future, we can use the 100% hydrogen combustor can be used. Okay. Then this is a test result on the co-firing, 30% hydrogen co-firing combustors. Mitsubishi Power has the combustion test facility in the Takasago factory. That test facility can test the single can combustor. Usually, our combustor has the 16 or 22 combustor in one gas turbine. Then we can test only one combustor in this test rig. But our gas turbine has a 300 or 500 megawatts. But only one combustor need only one combustor, but it needs huge energy. So we have such a big facility. Then this is the test result. So this is the co-firing rate. Then this is NOx emission. The increasing the hydrogen and the NOx is increasing because of the hydrogen has the high flame speed. So high flame speed, how to say, lost the premixing time and length. Then so NOx is a little bit increasing, but still in the 25 ppm. This picture shows a multi-cluster combustor. So we shorten the premix area to avoid the flashback phenomena. Then reducing, avoiding the risk of the flashback. But in that case, we need a small premixer. In this case, 250 premixer is needed. So this combustor looks like so rocket engines. Then okay, then this combustor is now under the development. Then 2025, we can start the engine verification or commercializing. The next topic is ammonia firing. The ammonia has a good hydrogen carrier, and also not only the carrier, ammonia itself can be used for the fuel. No CO2 emission, but ammonia combustion has a high NOx emission. Then we have two choices. High efficiency large flame gas turbine. Those gas turbine has a very high firing temperature, so that makes a very high NOx emission. So cannot use the ammonia directly. So we add the ammonia cracking system to use the gas turbine waste energy. Then apply the hydrogen combustor here. That is one solution for the large flame gas turbine. The small flame gas turbine has a little bit lower flame temperature. Then that can manage the NOx emission by the combustion technology itself. Then, but still, NOx is a little bit higher than the natural gas firing, so we need a SCR system, selective catalytic reactors. That means the DeNOx systems in the HRSG. Then this graph, this slide shows the schematic of the ammonia cracking systems. The ammonia is cracked by the exhaust gas of the gas turbines, then supply the natural nitrogen and hydrogen to directly go to the gas turbine. Then, so that reaction is like this. Ammonia cracking is a heat absorption reaction. So fuel energy is increasing by the this heat. So that means a new kind of the heat recovery system. Theoretically, we can increase the thermal efficiency of the gas turbine combined cycle. But actual system needs some heat loss. So now we are trying to reduce that heat loss. The ammonia cracking needs 600 degrees C reacting temperature. That is good for our gas turbines. Our high efficiency gas turbine has a 650 degrees C exhaust temperature. That is good for this reaction. The reactor is like this, a kind of the shell and tube type reactor. Okay, so then next is the ammonia direct combustion. Then last month we announced we start the development of the direct combustion system using the H25 40 megawatt gas turbines. Then this system, ammonia combustion, challenge for the ammonia combustion is poor flammability and high NOx. Then we use the Richlin two-stage combustor system in this engine. So air supply is separated into two portions. Then rich zone and lean zones here. Then this type of the combustor can reduce the NOx in 100 or some like that ppm in the NOx. Then finally we use the NOx system in the HRSG. Okay. Then we have some hydrogen GT project all over the world. Then today we quickly go through some very first one was like this Netherlands project. So then this one is the same types of the project in the UK. They also we saw the hydrogen gas turbine already in the United States. This system is this hydrogen is supplied from the salt cavern domes storage system. Okay. Then next is the solid oxide fuel cell (SOFC). We have two types of the SOFC. 200 kilowatt and 1 megawatt class. The good thing of the SOFC is the fuel flexibility. Hydrogen and natural gas, biomass gas, like this gas can be used in the same fuel cell. Mixing is okay. That is a good portion of these systems. And also the very high efficiency, 53% in the power generation. Then already we have the several orders in Japan, and last year we have first abroad order from Germany. Okay, next is last page. Mitsubishi Group has many products related in the hydrogen. So primary energy source, hydrogen production, transportation, and storage. No, of course, high hydrogen usage in power generation or gas engine or iron steel factories. So we can make such we can supply the total solution using our various products. That is my presentation. Thank you for your attention.
Thank you very much, Mr. Satoshi Tanimura, for your presentation. So our next speaker is Mr. Shinji Kondo. Mr. Shinji Kondo has been working at the Hydrogen Business Department in Sumitomo Corporation since 2020. He's now an assistant to General Manager, Hydrogen Business Department, Sumitomo Corporation. Mr. Shinji Kondo, time and screens are yours.
Yes. Can you hear me?
Yes, we can hear you.
Yes. Okay. Assalamualaikum. Ibu dan bapa, selamat tengah hari dan salam sejahtera. Selamat datang kepada semua yang hadir. Nama saya Kondo dari Sumitomo Corporation. Saya tinggal di Jakarta 3 tahun dari 2000. Tapi saya boleh bercakap bahasa sedikit-sedikit. So, let me allow to speak in English. So again, I'm Shinji Kondo, working in Hydrogen Business Department of Sumitomo Corporation. It is a great honor for me to participate in this workshop organized by NEDO. Today, I'd like to share with you about Sumitomo Corporation, our hydrogen activities, and finally, key elements to materialize hydrogen project. Next slide, please. This slide shows Sumitomo Corporation at a glance. Based on the last fiscal year, our shareholders' equity is $23.5 billion, and net income $1.6 billion. Number of employees at consolidated basis is more than 72,000 people. What I want to emphasize in this part is that Sumitomo Corporation has been ranked in the Fortune Global 500 for 25 years as one of the global leading companies. Next slide, please. Nowadays, most of the governments and companies have set the key social issues and long-term goals to create a sustainable society. In Sumitomo Corporation, 6 key social issues and their long-term goals have been made, as you can see in this slide. I believe hydrogen business is related to all issues, especially mitigation of climate change. Our long-term goal for this issue is to realize carbon neutrality by 2050 and the sustainable energy cycle. I re-emphasize that hydrogen should contribute to our long-term goal and create decarbonized societies. Next slide, please. We have 6 business units and deal with metal, transportation, infrastructure, media, foods, mineral resources all over the world. As you can imagine, our activities from the photos. Next slide, please. Aiming for realization of carbon neutrality, we have to integrate our core competencies and develop the energy-related businesses, which are shown in this slide. Vertical line represents a sort of a technical readiness level from establishment to under development. Horizontal line represents time frame from short, mid to long term. You can see 2 red boxes in this slide are related to hydrogen. The most right upper red box is supply chain of large-scale hydrogen production and transportation. Another red box is distributed hydrogen production and consumption. These positions are not satisfied with me and some of today's audiences. So in terms of technical readiness level, Nishimura-san and Tanimura-san continue to make it up towards commercialization. Then we try our best to materialize hydrogen-related business in Japan, Indonesia, Malaysia, or anywhere with adequate support from each government, especially from today's speakers. Next slide, please. Since the 1st of April this year, we have established a new business organization named Energy Innovation Initiative to create next generation businesses for realization of carbon neutral societies. Energy Innovation Initiative, we call the EII, has received human resources from 6 business units and centralized decision making for doing 3 pillars, as you can see in this slide. Making long story short, the purpose of EII is to create new business addressing to the social issues with a long-term vision. In other words, we commit to realize decarbonized and circular societies, which takes a long time, but we secure our resources for a long time to do it. Next slide, please. This slide shows EII's management and organizations. As you can see the right side in this slide, there are business department, teams, and projects in EII. I'll touch upon each activity briefly, except hydrogen business department, which will be explained later. Zero Emission Solution Business Department wants to proceed with energy management business using stationary battery, which are reproduced by second-hand batteries from electric vehicle, Nissan Leaf. Wood Resources Business Department has been proceeding with tree planting. Wood chip and the biomass department, as its name suggests, deal with wood chip and solid biomass. Both departments are or will be strongly related to Indonesia and Malaysia. Team Power Frontier intends to make up a distributed power system and virtual power plant. Subsurface energy team try to develop geothermal heat and power and carbon capture storage. Next generation bioenergy projects wants to proceed with second generation bioethanol project, especially. Next slide, please. From this slide, I'll explain on our activities related to hydrogen. We have joined the Hydrogen Council since 2018. We are also members of other hydrogen-related organizations in Japan, Europe, California, Korea, and Chile. In addition, we have participated in Global CCS Institute and Clean Fuel Ammonia Association in Japan to gather relevant information and expand networks in CCS and ammonia industry. Next slide, please. This slide shows projects we are currently promoting or pursuing opportunities globally. The projects shown in green box are local production and consumption. These projects aims to build distributed hydrogen supply chains that combines mobility, infrastructure, urban development, etc. Mainly in Japan, Europe, China, Australia, where are advanced hydrogen regions. Blue boxes shows large-scale value chain project. In terms of large-scale hydrogen production, we are focusing on Australia and Malaysia in Asian Oceania area because of abundant and reasonable renewable energy. In terms of hydrogen receiving and utilization, we have been promoting hydrogen receiving and distributing facility in Japan. Also, orange boxes shows investment in new innovative technologies to significantly contribute to cost reduction and scale up in hydrogen value chain. From the next slide, I'll touch upon our major hydrogen project investment and alliance. Next slide, please. This is a hydrogen production project in Sarawak, Malaysia. Sarawak is one of the best places in the world to produce green hydrogen with abundant and competitive hydraulic electric power generation, as Dr. Zaidel and Professor Dowd mentioned. We have signed an MOU with SEDC, an investment institution of the Sarawak state government, and have done pre-feasibility study of 1,000 tons per year of hydrogen production last year. And ENEOS, a Japanese major energy company, have joined the MOU since last October. Currently, SEDC, ENEOS, and we are in the process of study for both local consumption and export to Japan. We would appreciate it very much if Sarawak state government could support our projects. Thank you. Next slide, please. This is a social implementation project by the Hydrogen Utilization Study Group in Chubu, Japan, formed March 2019. Demand creation is a key in scale up and cost reduction of hydrogen, and the group is aiming at large-scale hydrogen import and utilization in Chubu region. Chubu is the name of the region in the middle of mainland Japan, including Nagoya, the third largest city. Chita and Yokkaichi are industrial areas. This is the first study group in Japan formed by cross-sectorial players such as power, gas, refining, petrochemical, as you can see the right part in this slide. In the group, we play a role as a secretariat with Toyota Motors and Sumitomo Mitsui Banking Corporation. Last year, we finalized pre-feasibility study and grasped the potential hydrogen demand in this region. This year, we will move forward, actually conduct a detailed feasibility study of hydrogen receiving and distribution terminal by utilizing Japanese governmental support. Next slide, please. I would like to explain about Gladstone Hydrogen Ecosystem Project in Australia. Gladstone City, in another name called as a Sunshine City, is blessed with a vast land and the sunshine, which covers approximately 314 sunny days per year. We have the footprint in this region on aluminum smelter and export terminal as well. Throughout our close relationship with state government and the city council, we have led the feasibility study since 2018 by engaging the key stakeholders, including the government, industry players, and engineering firms. This slide will be the flash shot we have agreed with the partners. Keyword will be phase gate approach. This approach will be inevitable to prove the range of hydrogen price and hydrogen production amount for local usage and export. By step-by-step approach, we aim to set the hydrogen ecosystem together with the government and the region. Actually, feasibility study has already been completed, and we have just entered into the front-end engineering design process for phase 1. In the following phase 1 dash, we plan to start study of conversion of trucks and buses to fuel cell vehicle. Furthermore, in phase 2, we are considering any possibility of the conversion of heavy machinery and ships to fuel cell, and also the conversion of mining machinery to fuel cell. Finally, we are targeting at export. Next slide, please. This slide mentioned as HESC project. This is already explained by Nishimura-san comprehensively. So just I touch upon the one point. We are heavily involved in on the CCS part in this project. In addition, we have also put our effort on regulatory approval and site option with hydrogen demand creation inside of this region. Our representative David Wilson is now chairing this demand creation group, Victoria Hydrogen Hub, which we aim to lay the stepping stone by starting from local production and consumption to seize this export story. Next slide, please. In terms of investment in new technology, we have invested in AP Ventures in UK as a limited partner since last October. AP Ventures is a venture capital specializing in the hydrogen value chain. Our aim to invest in AP Ventures is that we grasp trends related to hydrogen technology development, consider opportunities for direct investment, which AP Ventures gives our limited partners, and pursue the possibility of applying new technology to our projects. In addition to AP Ventures, we directly invest in some startups through our corporate venture capitals. The upper right is CZZ in the United States, who are developing photocatalytic technology for hydrogen production by reforming natural gas. Another startup we invested is H2 Pro in Israel. They are developing the next generation technology of electrolyzer. Next slide, please. We have made a strategic partnership agreement with ITM Power, who is a PEM electrolyzer manufacturer in UK, with abundant supply records of multi-megawatt electrolyzer. We have an exclusive right to deal with ITM's products in Japan, and also ITM cooperate with us technically and commercially on our project out of Japan. 1H2 is US-based hydrogen production and distribution company who have been actually doing businesses with US Post, GM, Toyota. We invested in 1H2 January this year. We try to utilize 1H2 competitive distribution solution in last 1 mile delivery of our project. Next slide, please. Okay, let me summarize my presentation. It is no doubt that the hydrogen is a key element to develop sustainable and decarbonized society in future. In order to materialize and implement those hydrogen projects, we strongly believe that collaborative efforts among government, industry, and technology are quite essential. At first, we need to have governmental support and commitment, such as roadmap and related policy setting and reformation. At the same time, governments would create an enhanced local demand as well for making their own decarbonized society. Secondly, industry players need to incubate global and local demand and establish sustainable hydrogen supply chain, co-working with government and other industry players. Contribution to local society, such as transferring the knowledge and business model, is also important for its sustainable development. Thirdly, development and utilization of technology for cost reduction and efficiency improvement are very important for realization of hydrogen business. Finally, I re-stress that we Sumitomo Corporation are eager to and strongly commit to materialize sustainable societies and circular economy by utilizing hydrogen in collaboration with all relevant parties. That brings me to the end of my presentations. Thank you very much for your attention.
Thank you, Mr. Shinji Kondo, for your presentations. So now we're welcoming our last speaker for this webinar is Mr. Masaki Sakamoto. Mr. Sakamoto is an electricity section research and development judge sub-chief in Yamanashi Prefectural Enterprise Bureau. In this presentation, Mr. Masaki Sakamoto will present his material in Japanese and will be translated by interpreted into English. So, Mr. Masaki Sakamoto, time and screen are yours.
よろしくお願いします。日本語で失礼します。
Good afternoon, ladies and gentlemen. Sorry, I speak in Japanese and translate it into English.
山梨県における CO2 フリー水素社会を目指した P2G システム技術開発について説明いたします。
And the topic is the development of P2G system technology, aiming to build a CO2-free hydrogen society in Yamanashi Prefecture.
まず、山梨県の説明をします。山梨県は日本の、ほぼ中央にある内陸県で、日本の高い山が集中している県です。人口80万人です。
Firstly, let me introduce our Yamanashi Prefecture. It is at the center of the Japanese mainland, and the three highest Japan's mountains are located in the prefecture, and we have about 800,000 population.
山梨はですね、非常に豊かな自然が日本の中で残っているところで、有名です。
And we are rich in beautiful nature.
その山梨県で、我々は、公営企業を営んでいる事業体になります。独立採算の公営企業です。
And in this Yamanashi Prefecture, I am in the Enterprise Bureau of Yamanashi Prefecture, and it is a municipal utility, and we have a self-supporting accounting system.
温泉事業、地域振興事業、電気事業の3つの事業を経営しています。
And we have three businesses. One is hot spring supply business, and the second one is regional promotion business, and the third one is my electricity division, electricity business.
そしてですね、その中で、一番、今日関係するのが電気事業ということで、水力発電所を27箇所、持っていまして、さらにですね、太陽光発電所5箇所。こちらで、販売しているのはすべて再生可能エネルギーという事業者です。
And in my electricity power division, we have 27 hydroelectric power plants and 5 solar power plants. And we are selling power, and it is all generated from renewable energy.
そうですね。電気事業の、実力ですけれども、水力発電が 12.1 万キロワットで年間5億キロワットアワー。そして太陽光発電所が1メガワットで山梨県の電力の約 8% を供給しています。
And our hydraulic power plants produce 121 megawatt, about 500 gigawatt per year, and solar power plants generate 1,000 megawatt. And we provide about 8% of all demand in Yamanashi Prefecture.
電気事業の技術力と収益を生かして、CO2 フリー社会の構築を目指した技術開発を行っているところが、米倉山という場所です。
Sorry, in solar plants, we supply 1.1 megawatt, and we are developing technology to build carbon-free society with our expertise and our revenue. And research is mainly done in Komakurayama mountain area.
東京電力と共同事業で1万キロワットの、発電所をですね、2012年に作りまして、それから、開発を始め、12年が経っています。
And we have developed the solar power generation together with TEPCO, and we have developed from the 2011, and since then about 12 years have passed.
主にですね、2つの施設がありまして、環境学習の、展示施設、夢ソーラー館山梨と、電力貯蔵技術の、研究サイト、この2つを、有しています。
And in Komekurayama site, there are several facilities, and we have two major ones. And that one of them is Yume Solar Hall Yamanashi, and that is the place where the visitors can learn about environment and energy. And the second major one is Electric Power Storage Technology Research Site.
電気をですね、上手に利用する蓄電のコンセプトとして、電気の性質に合わせ、蓄電している時間の長さにより、それぞれの蓄電システムの実証を行っています。これは夢ソーラー館、電力貯蔵技術サイト共通の、ことです。
And how to use or store electricity efficiently, that is our main theme. And depending on the length of power storage period and considering electricity characteristics, we came up with several ways of storage systems. And currently, we were doing demonstration tests. And we apply this same concept to Yume Solar Hall and also the Power Storage Technology Research Site.
ですね、単周期蓄電、これは電気の性質でいうと、完成力や周波数に当たる部分、これをがまず第一、2つ目が、中周期として電圧とピークシフト、3つ目に、長周期の電力貯蔵ということで、電力量に対応する、蓄電、この3つをそれぞれに行っています。
And for short period power storage, it has the electricity characteristics of inertia and frequency. And for the medium period power storage, that character is voltage and peak shift. And for the third one, that is long period power storage, we have to deal with the electric energy amount. We need to address these amount of electricity to develop technology for power storage.
啓発施設の夢ソーラー館でやっている、電力貯蔵の、状況を説明します。
And this is what we are doing at Yume Solar Hall. What we are doing in this hall as EMS.
太陽光発電の電力、オレンジ色で示しています。
The orange one is solar power generation.
館内の使用電力は水色です。
And the light blue, that is the energy consumption in this area.
この間のですね、調整力を紫色のバッテリーで供給します。
And between this generation and the consumption balance, we use the capacitor and the battery to stabilize. And that is lined in purple line.
緑色のラインで示しているのが、水素、発生量で、蓄電しきれない部分をですね、水素に変換しています。
And the green line, that is the hydrogen production, and we store the unstored power into this hydrogen.
変動するですね、太陽光発電の電力と、館内の消費電力をですね、すべて館内で、使用し尽くせるという、将来のですね、電力グリッドのあり方を、検討しています。
And we are exploring the best way for the future grid system to have the good balance between the fluctuating solar energy and also the consumption used in this solar Yume solar hall.
電力貯蔵技術研究サイトの方に移ります。
And now go to the electric power storage technology research site.
まずですね、回転エネルギーへ、電力を変換することで、エネルギーを貯蔵する超電導フライホイールシステムを単周期蓄電として技術開発しています。
We have developed superconducting flywheel energy storage system, and it is used for short-term electricity storage, and we change the energy power to rotational energy.
次にですね、ハイブリッド水素電池を開発しまして、こちらは、中周期のですね、電池としてやったんですけれども、高い、重放電性能を持った電池を開発しています。
And next one is for the storage for mid-term, and we have developed hybrid hydrogen storage system, and that can do the quick charging and recharging.
で、近年ですね、新たな取り組みとして実施しているのが、太陽光発電の不安定な電力から水素を作り出す、パワートゥーガス、技術開発です。プロジェクト名を H2ES と命名して、地域の化石燃料を CO2 フリー水素に置き換える実証をしています。
And now we are doing another project that is P2G project. That is change the production of energy to H2 hydrogen. And by conducting this experiment, we try to convert the energy by the fuel cell replaced by the hydrogen, which is emission free. And we call the project H2YES, or Hydrogen Yamanashi Hydrogen Energy Society.
ですね、発生した水素は、こちらにありますね。今、ポインターに、すみません、ポインターのこのあたりですね。地域のですね、工場の、化石燃料を使っているボイラーの燃料を代替することを目標にしています。
And the fossil fuel that is used in boiler in our regional area would be replaced by the hydrogen. That is our target.
プロジェクトメンバーは、山梨県企業局を代表委託先として、水電解材料の先進メーカーである東レ、エネルギー供給サービスをする東京電力、そして東京電力の、グループ企業の、東工高岡、この4社で行っています。
And in this project, we are the leader in this project. We as Enterprise Bureau and Tore, that is a leading water electrolysis material manufacturer, joined, and also TEPCO Holding, that is major energy supply service company, and also Takaoka, that is a group company of TEPCO, and electric product manufacturer and dealing with EMS. These 4 members are the project members, and we are representative.
ですね、水素の製造から利用までを一貫して行う技術開発を推進するために、水電解のメーカー、輸送業、工場、小売業者などを巻き込んだ、実証体制を、構築しています。
And also, other companies are joined too, like electrolysis-related manufacturer and transportation industry and factories and retailers and so on. We need all of them to achieve technology development from end to end. So these are the system to do demonstration.
我々の、目標ですけれども、まずは 1.5 メガワットの規模で、水電解装置を作ることです。
And our goal is, firstly, building 1.5 megawatt electrolyzer.
効率ですけれども、性能面 で、2020年の実証時点において 74% の変換効率。そして2030年で 80.5% と置いています。
And the next, in terms of performance, our target is achieve high efficiency of electrolyzer system. By 2020, achieve the conversion rate of 74%, and in 2030, the target is 80.5%.
技術開発はステップバイステップで行ってきておりまして、大型スタックの建造前にですね、電極面積は同一のショートスタックを用いた試験を2年間実施しました。これによってですね、電解層の開発に目処がついているところです。
And we are developing technology step by step. Before constructing full stack, we tested with short stack. The surface area of the electrode used in the short stack was the same as that of the full stack. And we ran the test for 2 years. And finally, we have got confidence in development of the electrolyzer of this kind.
この、小規模な実験でですね、これまでにできている技術は、大面積の膜電極接合体、その積層技術、そして、電源供給技術、この3つを、これまでに、獲得しています。
And as of today, we have achieved the technology for MEA with large surface area and stacking technology, and also the power supply technology.
2016年からスタートした実証は現在6年目にあたり、2021年の春からですね、いよいよ水素を使う実証を開始する予定です。
And this is the 6th year since we have started the demonstration. And from this spring, finally, we'll start to use the produced hydrogen in real society.
具体的に6月7日からですので、また皆さんぜひご視察にいらしてください。
And specifically, we start the demonstration from June the 7th. So I really hope please come and visit us on this day.
先に述べたですね、システム効率 74% を達成するためには、水電解のですね、効率は 88% が必要だと考えておりまして、その効率について、目処がついています。
And as I said before, the system efficiency 74%, that was the target. And to achieve this system efficiency, the electrolysis efficiency of 88% was needed. And we almost achieved that target.
ですね、将来の、80.5% に、対応するための、水電解効率も、達成に目処がついています。
And also to achieve the second step target of the system efficiency of 85%, we think it's feasible.
ですね、テム型水電解の特徴として、電力変動への強さが挙げられるんですけれども、図の通りですね、指令に対して高い追従性能を確認できています。
And PEM-type water electrolysis has high durability against electric power fluctuation. And as you see in this graph, there is high responsiveness or high followability to the command current value.
また、水電解装置は大きく連続的な電力変動によって劣化することが知られています。左の通りですね、太陽光発電の変動データ、一番変動した日なんですけど、このデータをもとに、試験を重ねてきましたけれども、100回連続ですね、かけてもですね、これは劣化しないということが確認できています。
And also it is known that water electrolysis material deteriorates due to continuous big change of power. But we found no obvious deterioration confirmed in the fluctuation test. And in the left slide, it shows the big fluctuation of power of one day. And with this power plant, solar plant data, We repeated the test 100 times, but we confirmed no deterioration on the water electrolysis material.
現在準備中のですね、1.5 メガワットの水電解層は、10メガワットの太陽光発電の電力で、水電解を行い、圧縮装置で、20メガパスカルに、してからトレーラーで配送することにしています。
Currently, we are developing the 1.5 megawatt water electrolyzer, and it will use electric power generated from 10 megawatt PV power plant, and hydrogen produced will be compressed to 20 megapascal and will be delivered by trailer for use.
山梨県は県全体として水素燃料電池に取り組んでおりまして、山梨大学では1970年代から燃料電池の開発を行い、その他にもですね、燃料電池の評価試験場や水素ステーションの研究施設が集約しておりまして、まさに、山梨ハイドロジェン&フューエルセルバレーを目指して取り組んでいます。
We are achieving to become Yamanashi Hydrogen and Fuel Cell Value because we are working very hard as a prefecture of hydrogen fuel cell battery development. And since as early as 1970s, University of Yamanashi started fuel cell technology development. And in our prefecture, a lot of related facilities are concentrated in our prefecture. We have fuel cell performance evaluation lab and hydrogen station research facilities, for example.
我々のプロジェクトを、応援してくださるNEDO様に、日頃からのご支援を感謝、申し上げます。ありがとうございました。
In conclusion, taking this opportunity, I'd like to thank NEDO for their great support. Thank you very much for your attention.
Thank you, Mr. Masaki Sakamoto. Well, ladies and gentlemen, we have finished the second session, which also means that we have completed the whole series of Future Outlook for Hydrogen Energy in Southeast Asia, featuring Indonesia and Malaysia webinars today. Before we end this webinar, on your screen, there is a link and QR code. You can access the evaluation form for today's webinar, and you can also access the link as we have shared in the chat box below. And also the materials presented today will be automatically emailed to you after you fill out the evaluation form. On behalf of NEDO, we would like to express our deep appreciation and gratitude. Thank you very much to Honorable Ms. Yoshiko Yurugi from NEDO, Asian Representative Office in Bangkok, that have presented the opening remarks for today's webinar, and all the honorable speakers from Japan, Malaysia, and Indonesia who have given their times and energy in preparing their presentation materials and have given us a very interesting and valuable knowledge. And also to all participants who have participated in today's webinar. We really hope everybody found today's webinar is valuable and will provide one-off stepping stone in supporting the development of hydrogen energy in Southeast Asia that we all hope can be established in the near future. I am Aditi Desani as today Master of Ceremony on behalf of today's webinar organizer, Indonesia Research Institute, Japan, Jakarta. Also would like to express our gratitude, and we strongly hope that we can meet again in any future webinar. Thank you very much. Have a great week ahead. Thank you.
Thank you. Thank you, everybody.
Thank you very much, everybody.
Hello, thank you. Nice to know you, Mr. Muhammad Abdullah.
Yeah, thank you,
good,
Professor.
Progress in Sarawak, ya?
Yeah, alhamdulillah. Maybe one day Prof datang Sarawak.
Ya, sangat ingin ini saya ke Sarawak tuh, dekat.
Thank you,
I
Prof.
heard about you from Prof. Wan Ramli.
Oh, thank you, Dato'.
He explain the progress of the hydrogen development in Sarawak.
Yeah.
Yeah, it was good to know it.
Hopefully we can do one physical, Dato' Professor Wan. We can do one physical conference later on once COVID is okay.
Sure, yes.
Yeah.
Sure. Yurugi-san, arigatou gozaimashita.
Yes, thank you very much.
Thank you very much.
Yeah, thank you very much.
Thank you
Thank
very
you for
much.
Okay,
Nedo.
bye-bye. And selamat
Yeah.